A black hole is a region of space where gravity is so strong that nothing, including light or other electromagnetic waves, can escape it. Black holes are formed by the collapse of very massive stars or the merger of smaller black holes. Black holes have different sizes and types, depending on how they were formed and how much mass they have. The smallest black holes are called primordial black holes, and they may have formed in the early universe when matter was very dense. They have the mass of a large mountain, but are as small as an atom. The most common black holes are called stellar black holes, and they have the mass of up to 20 times that of the Sun. They are formed when massive stars explode in supernovas and leave behind a dense core that collapses under its own gravity. The largest black holes are called supermassive black holes, and they have the mass of millions or billions of suns. They are found at the centers of most galaxies, and they may have formed from the collapse of huge gas clouds or the merger of many smaller black holes. Black holes are invisible because they do not emit or reflect any light. However, scientists can detect them by observing their effects on the surrounding matter and radiation. For example, if a black hole is close to another star, it can pull gas from the star and form a disk of hot material around it. This disk emits high-energy light that can be seen by telescopes in space. Another way to detect a black hole is to measure how it bends the light from distant objects behind it. This phenomenon is called gravitational lensing, and it creates distorted or multiple images of the same object. Black holes are fascinating and mysterious objects that challenge our understanding of physics and reality. They can reveal secrets about the origin and evolution of the universe, the nature of space and time, and the possibility of other dimensions and parallel worlds. What is event horizon of a black hole? The event horizon of a black hole is the spherical outer boundary of a black hole that marks the point of no return for anything that crosses it, including light. The event horizon is not a physical surface, but rather a mathematical boundary that depends on the mass, charge, and spin of the black hole. The event horizon is also the place where the escape velocity, or the speed needed to escape the black hole's gravity, is equal to the speed of light. Since nothing can travel faster than light, nothing inside the event horizon can ever escape or communicate with the outside world. The size of the event horizon is proportional to the mass of the black hole. The radius of the event horizon is called the Schwarzschild radius, and it is given by the formula equals 2 equals C22 gm, where g is the gravitational constant, m is the mass of the black hole, and c is the speed of light. For example, a black hole with the mass of the Sun would have an event horizon with a radius of about 3 kilometers, 1.9 miles. The shape of the event horizon can vary depending on the charge and spin of the black hole. A non-rotating black hole has a spherical event horizon, while a rotating black hole has an oblate spheroidal event horizon that is flattened at the poles. A charged black hole has an event horizon that is slightly smaller than a neutral black hole with the same mass and spin 3. The event horizon is one of the most mysterious and fascinating features of a black hole. It is also one of the most difficult to observe, since it does not emit or reflect any light. However, scientists can infer its existence and properties by studying its effects on the surrounding matter and radiation, such as gravitational lensing, accretion disks, jets, and Hawking radiation. What is singularity? The singularity of a black hole is the theoretical point where all the mass of the black hole is concentrated, and where the laws of physics break down. It is a region of spacetime where gravity is so strong that nothing can escape, not even light. 2. There are different types of singularities, depending on how the black hole was formed and what properties it has. For example, a non-rotating black hole has a spherical singularity, while a rotating black hole has a ring-shaped singularity. A charged black hole has a smaller singularity than a neutral one. The singularity of a black hole is one of the most mysterious and fascinating aspects of astrophysics, as it challenges our understanding of reality and the nature of the universe. However, it is also one of the most difficult to observe or study, as it is hidden behind the event horizon, the boundary that separates the black hole from the rest of the world. Some scientists have proposed alternative theories or models to avoid or explain the singularity, such as quantum gravity, Planck stars, or gravistars. However, these are still speculative and not well tested by experiments or observations. Therefore, the singularity remains a puzzle and a paradox for modern physics. Stephen Hawking was a brilliant physicist who made many contributions to the field of black hole physics. He proposed several theories and discoveries about the nature and behavior of black holes, some of which are Hawking's area theorem. This theorem states that the total area of a black hole's event horizon, the boundary beyond which nothing can escape, can never decrease over time. This implies that black holes can only grow or merge, but never shrink or split. 2. This theorem was recently confirmed by observing gravitational waves from the merger of two black holes. Hawking radiation. This is the process by which black holes can emit radiation and lose mass, due to quantum effects near the event horizon. Hawking showed that black holes are not completely black, but have a temperature and entropy that depend on their mass, charge, and spin. Hawking radiation is very weak and has not been detected yet, but it implies that black holes can eventually evaporate and disappear. Information paradox. This is the puzzle that arises from the apparent contradiction between quantum mechanics and general relativity regarding the fate of information that falls into a black hole. Quantum mechanics suggests that information is conserved and can never be destroyed, while general relativity suggests that information is lost inside a black hole and cannot be recovered. Hawking initially argued that information is indeed lost, but later changed his mind and proposed various ways to resolve the paradox, such as holography, wormholes, or baby universes. These are some of the most famous ideas that Stephen Hawking taught us about black holes. He was a visionary scientist who advanced our knowledge of the universe and inspired generations of people with his curiosity and courage. Thanks for watching this video. If you enjoyed watching this video, please like and subscribe to my channel.